Welcome back. In Lesson 8, we are taking our most significant operational step yet, building Alex's first skill. Subtitle, Turning Knowledge into Repeatable Execution. Alex now has identity, boundaries, and organized knowledge. But knowledge alone doesn't create reliable execution. Today, we bridge the gap between knowing and doing by building Alex's first repeatable job. Without skills, your worker must reason through every request from scratch. This creates inconsistency. One response is perfect, while the next skips a step. Skills provide the structured path for consistent, repeatable work. A skill is more than just a paragraph telling the worker to do its best. It is a structured, reusable operating procedure that defines exactly how a specific type of work should be handled every single time. A prompt is a temporary instruction for one moment. A skill is a permanent operating procedure that defines inputs, decision logic, and completion criteria. It transforms an agent from an experimental chatbot into a reliable worker. Choosing the right first skill is critical. We've selected operational request intake because nearly every other workflow begins with understanding exactly what the user is asking for. It's the gateway to the rest of the system. Before Alex can execute work, he needs to determine what is being requested, what outcome is expected, and what authority is required. This skill ensures that every subsequent process starts with a complete and actionable work item. Every skill begins with a clear purpose. We define the outcome, not just the steps. Our goal is to convert an incoming request into a classified, authority-checked work item or a structured escalation. The trigger tells Hermes when to activate this specific logic. It shouldn't fire for every message. Small conversational questions don't need a formal intake. We only activate when a structured operational outcome is needed. A reliable process begins with reliable data. Alex should never guess silently when critical information is missing. We define required fields like the description and outcome, and conditional fields like deadlines or project context. By explicitly listing these inputs, we make missing information visible. If a user asks Alex to prepare the update without saying which project, the skill will stop him from guessing and force him to ask for that missing context. Alex now needs a useful classification system. We aren't creating dozens of complex categories. We're giving him just enough structure to support the next decision. We've defined 9 core request types. These range from simple information retrieval to high-impact system actions. By identifying whether a request is an internal update or a legal commitment, Alex can immediately determine the appropriate risk level and authority required. Request type alone is not enough. We must also identify consequences. We use 3 risk levels: low for internal summaries, moderate for external messages, and high for payments or infrastructure changes. Risk determines authority. This risk classification is the bridge to Alex's permissions. It ensures that he only executes what he is authorized to do and prepares everything else for your explicit approval. This is how we move from identity to execution logic. The skill logic connects these layers. It asks, is it in my role? Do I have enough info? Is it allowed? Can I execute it? The outcome is never a guess. It is a calculated decision based on the rules we've built. We create a dedicated directory for our skill, keeping our configuration isolated and understandable. This folder will hold our definition, our logic, and the tests that verify Alex's behavior across different scenarios. The main skill.md file explains what success looks like. We define the primary outcomes, like producing an actionable work item or a structured escalation, and list the required behaviors Alex must follow. We include rules like use approved knowledge before assuming and never claim execution without verification. This file acts as the mission statement for this specific repeatable task. It ensures Alex remains disciplined and accurate. In inputs.yaml, we codify our validation rules. We specify minimum lengths for descriptions and outcomes to prevent Alex from acting on vague or one-word requests. We're building stability into our data intake. This schema ensures Alex always knows what is missing. Instead of guessing a deadline, he will see it as an optional field and only act if it's provided, or ask if the process requires it. This is the difference between a bot and an assistant. The workflow.md file is the step-by-step roadmap. It guides Alex through reading the request, retrieving vault knowledge, validating inputs, and selecting the correct outcome. Let's look at the 10-step sequence. We include critical gates, like step 6, check authority. This forces the agent's logic to consult the permission profile before any action is selected. It ensures that the process always respects the security boundaries we established in Lesson 6. Decision logic prevents the skill from becoming a static checklist. Alex must choose the correct route based on the request. We use simple but powerful logic chains to determine if he should execute, prepare, or escalate. If it's outside his role, he refuses. If it's high risk, he escalates. This logic should be enforced in your runtime configuration where possible. Natural language is for behavior. Structured rules are for authority. This is how you engineer safety. Structured output is more reliable than an unstructured paragraph. We define an output schema so that Alex returns a predictable object containing his classification, his risk assessment, and any blockers he's identified. This schema allows you, in future applications, to process Alex's responses programmatically. You can immediately see if a task is escalated or prepared without having to read a long message. It transforms agent communication into actionable data. The skill must also use the knowledge vault. We update the configuration to require vault access and specify which folders Alex should prefer for this operational role. He should cite his sources every time. By pointing Alex toward the processes and systems folders, we ensure he finds the request intake process and system documentation before he tries to reason from general training data. Grounded knowledge is trusted knowledge. A skill is incomplete if it doesn't define what done means. We establish clear completion criteria. The request must be classified, authority checked, and the output must match our structured schema. A confident answer is not a completed process. When Alex escalates, he shouldn't just send a warning. He should provide a structured report. He tells you what he attempted, why he stopped, and what he recommends you do next. This is how an AI worker supports a human architect. We provide examples of successful, incomplete, and prohibited requests. These act as the tests for the model, showing Alex exactly how to respond when a user asks for something outside his role or authority. Let's validate our skill. Never activate a skill until it has been validated. We confirm the files exist, the YAML is parsable, and there are no permission conflicts. Once the check is green, we load the skill into Alex's profile. Your worker is now capable. Now we test. We run a complete request, summarizing project notes, which he should accept. Then we run an incomplete request, create the update, which he must refuse to guess and instead ask for the missing info. Logic in action. By testing refusal and escalation, you confirm your security policies are actually being followed. This is how you ensure that your worker remains an asset, not a risk. Predictable behavior is the difference between a demo and production. Avoid the common mistakes. Don't make skills too broad, never skip input validation, and always define a failure path. A single skill shouldn't manage every business function. Separate your concerns for stability. Hiding logic inside one enormous file or treating examples as the only enforcement are signs of a weak architecture. By following these professional standards now, you are building a system that is reliable, scalable, and easy to maintain. Pause here and verify that your first skill is complete. If you've defined your purpose, documented your workflow, and passed your validation tests, you have just given your AI worker its first repeatable professional capability. Take a moment to verify every item. If Alex is classifying requests and checking authority correctly, you have just reached a major milestone in your journey as an AI systems architect. You are now building real operational leverage. Let's look at the stack. Alex has identity, knowledge, and now a repeatable skill, but he still cannot take meaningful action inside external systems. That is our next step, giving Alex authorized tools and permissions. In the next lesson, we will introduce tools so Alex can move from preparing work to interacting safely with real-world applications. We'll establish the precise controls that determine exactly what your worker is allowed to do. Today, Alex learned how to follow a professional process consistently. He is no longer just a model that responds. He is a worker that follows a procedure. I'm Brian Jones, and I'll see you in the next lesson as we give Alex his tools. Let's keep building. Lesson 8 complete. Alex now has a repeatable skill. In the next lesson, we give him tools and permissions. I'll see you there.